Okay, now we're going to use our knowledge of charges that we learned about from J.J. Thomson's model and from our sticky tape lab. And it's just a straightforward process if you'll just follow the process every time for any ionic compound, which is a metal and a nonmetal, something with a positive charge and a negative charge. You start by writing the symbols, francium, and then for chloride. Then you write their charges. Francium is in group 1, so it is a +1. Chloride is in group 7, so it is a -1. And then you cross the numbers. Bring the 1 down here. We don't write 1. Let's bring the 1 down there. So francium chloride's formula is FrCl. It works for every ionic compound, a plus and a minus, a metal and a nonmetal. You write the symbols, lithium, nitride. You write their charges, group 1 and group 5, and you cross them. You bring this 1 down here, and you don't write it. You bring this 3 down here, and you write it. The formula is Li3N. And it should make sense that if you have a single nitrogen with a 3- charge, you are going to need 3 +1 lithiums in order to balance it out. You're going to need 3 lithium atoms to balance out the 1 nitrogen atom. I'll just do some more examples that show a little more of what we're doing here. We have magnesium phosphate. It's a metal, positive thing and a negative thing, so it is ionic. So we're going to write the symbols. Phosphate is a polyatomic ion. You have a list for those. You're going to write their charges. Magnesium is in group 2. Phosphate is a -3. You just look it up. So symbols, charges, then you cross those numbers down. The 2 comes down here and becomes the subscript for the phosphate, and the 3 becomes the subscript for the magnesium. And we know as part of our rules it was symbols, charges, cross them, and then you reduce, if possible. Well, you can't reduce the 3 and the 2 anymore, and parentheses if necessary. Since we have 2 phosphate ions, we know that, just from algebra, for that 2 to apply to the entire molecule, we're going to have to put the molecule in parentheses. So on a particle level, we have these 2 magnesium particles, or 3 magnesium particles, sorry, and we're going to have 2 phosphate particles. And the key is that the phosphates being 3- and the magnesiums being 2+, the charges are balanced. 2+, 2+, 2+, that's a total of 6+ for the magnesiums. 3- and 3-, that's a total of 6- for the phosphates, so it is indeed balanced. So the formula is Mg3PO42. One more example. Iron 3 oxide. We're going to talk about this on the second day of writing ionic formulas before we move on to covalent. We know that everything in group 1 has a +1 charge, and everything in group 2 has a +2 charge, group 3 is a 3 charge, and so on. But our transition metals in the middle of the periodic table have varying charges. And that's okay. When the name is written out, you'll always be given the charge. You don't have to go look for it on the periodic table. Iron is a transition metal. It forms different charges, sometimes 2, sometimes 3, or 4 even. But in the written out word, it will always be given to you. Oxygen is in group 6, so it's a -2. But you're going to write the formula exactly the same way as you did with any of the others. You're going to write the symbols, the charges, and for iron it's 3, oxygen is 2, and cross them. Symbols, charges, cross them. You can't reduce, so the formula is Fe2O3.